Hey, good morning. Let's make this quick. We're starting Boyle's Law for Chem 100. This question right here, it's on your... This question right here, a helium-filled balloon is like one Friday's night football game. As the balloon increases its altitude, what happens to the size of the balloon? Explain the reasons for the change in size using the key vocabulary. That particular question is a answer that question for demonstration of participation for attendance. You'll find it on your assignment that I'm going to be showing you here in a second. The next thing is this. There's a relationship between pressure and volume. Now, pressure is like that. It's a force pressing down on us, all around us, and it's dependent upon area. The larger the area, the force goes small. Imagine walking on ice compared to crawling across icy pond. If you're walking over an icy pond, you could imagine that you might break through easier than if you were laying down. So anyway, the units of pressure we use will be pounds per inches squared or newtons per meter squared, which is 1 Pascal. Standard temperature and pressure. This is what's measured at sea level. This is what is our go-to. This is the unit we'll normally be using. Pounds. This is how many pounds. 14.7 pounds per square inch is pressing down on us at sea level. So that's the amount of pressure. So imagine if there was layers of atmosphere pressing down on us. They change if you're at sea level down below to when you're at a mountain up top. So you have greater pressure pressing down on you when you're at sea level than you do if you're at a mountain, like where we live. 1 atmosphere, 760 millimeters of mercury. These are all standard temperature and pressure, just different types of units. And we also use 760 torr, torricelli. We can also use this right here, but most cases we're going to be using these three. That's the one. Remember this one. Make sure you guys remember that this will be our main unit for measuring pressure. 760 millimeters of mercury. Now, Boyle's law, a volume of gas varies inversely with pressure. That means if one goes up, the other goes down. Pressure increases, volume decreases, and vice versa. The formula is a P1 V1. That means your starting pressure, your starting volume of that container. Let's say the temperature changes, or we won't mention temperature yet, that's a different law. But let's say the pressure changes and it becomes this. What's going to happen to the volume of that container? If the pressure went up, then this volume goes down. If this pressure went down, then this volume will go up. And these two can be used to solve for any of the missing parts. So the starting volume, using these units, milliliters, liters, cubic centimeters, or cubic centimeters, just written in a different way. Ending volume, this is what we're usually looking for. Starting pressure and ending pressure. That's what those letters stand for. And these are the units that you would use when dealing with pressure. P1 if it's in atmospheres, P2 should also be in atmospheres. V1 if it's in milliliters, V2 should also be in milliliters. And all of these for V1 could be used, but make sure it's the same unit for both. And likewise for pressure. Here's an example. You have a balloon with air in San Francisco. A balloon has 3 liters at 760. Okay. And then you bring it to Carson where the balloon, the normal pressure is 680. Okay, because it's not at sea level. Okay. So the idea is that the pressure has changed. And we're going to have to deal with that and figure out what is the new volume going to be, okay? So let me get a pen here, and let me show you this real fast. Hey, computer. So we got P1. Oh, that's a good one. Did you hear that? P1 V1 equals P2 V2. So in this scenario, it's telling us that we have a volume of 3 liters there in San Francisco, with the pressure being 760 millimeters of mercury, okay? And that's 3 liters. So we have a new pressure now of 680, so you can see the pressure has gone down. And now we're looking for the new volume. So we're looking for the new volume. The V2 is our unknown. That P2, these are all multiplied if they're next to each other. Okay. So imagine you go 760 times 3 liters equals your 680 mmHg. Now we're looking for this V2. Okay. Looking for that V2 right there. So we're going to divide by 680 on both sides. And it's a mmHg. You can see that these duplicate units are eliminated. 760 times 3, and that unit L stays, divided by 680. So the amount of volume that you would get, okay, so notice, our pressure went down to 680. So what should this volume do? If pressure goes down, volume should go up. So when you calculate this, your volume should be greater than 3. So it should increase. It should increase. Okay, so back to this. Good job on that. Way to maintain. Okay, let's see. So like I showed you, we worked it out. We're going to divide by 680 now, solving for V2. Okay. We're using these. Anyway. All right. Okay, we're not going to do Charles' law today. We're going to do Charles' law next time. But I do want to show you your Google Classroom for, let's just use B2. Your classwork here. Got one person already turned it in. But you have 2 videos. One video showing how to do Boyle's problems, which is pretty easy. And then you have a video on marshmallows. And this lab sheet goes with this. Now, if you do this on your own and show me using pictures or video or whatever, you get extra credit. However, there is this document here. You click on this activity 8.4. This answer sheet goes with this. So this answer sheet here, there's 6 problems that you have to do using that formula I showed you. And that's what you have to do. Okay? Now it tells you right here, answer sheet, that's this one, and the marshmallow lab sheet. Those are the 2 things that you need to do to turn in. Now, am I missing anything? I think you're all good. If you have any questions, please put it into the box. I also asked a question there at the beginning of your stream is, does anybody have a Zoom meeting? So I asked that, but respond if you do. Somebody says post a video. I can see that right there. Perfect. Got it. That's what I'll do. Thanks, guys. You have a great day, and happy Easter.